Yeah, so you've got your objective. We're going to apply enlargements. So just to say, something to consider, an enlargement does not necessarily mean larger. It could also be smaller. Now, we've already talked about shapes that are the same shape but larger, and they are called what shapes? Done. Similar shapes. That's why I put it on there. Understand the relationship between lengths and areas of similar shapes. So when you apply an enlargement, you have a similar shape. When you apply a translation, you get a what type of shape? What's the word? Congruent. Good. If you do a reflection, you end up with a congruent shape. Still congruent. If you do a rotation, you end up with a congruent. Are congruent shapes similar shapes? Yeah, they are. They're just, we call them congruent. They are still similar. But enlargements are not congruent because they're larger or smaller. All right? So we've got to be able to do certain things, like apply an enlargement or be able to describe an enlargement. How many marks would you say an enlargement, if you were to describe an enlargement, would be worth? What do you think? Leah? 3, 2, 4. Well, what are the 4s for?
Because of the 4 things we need to be applied.
Well, what are they then?
Apply the enlargement.
No, that's not what you'd have to do in a question. Not all of those in one question. If you had to just describe, this shape has been transformed, what is it? And you decide it's an enlargement. No. So what if I said, when considering enlargement, you must state it's an enlargement and scale factor and the centre of enlargement. So that's why I put that line there again. So how many marks are you expecting? 3. So when you apply an enlargement, you actually do the drawing, there might be other marks available. So when I say there are 3 marks available, it's only really for when you have to describe one. Right, so let's have a look at the sheet. Okay. So we're going to do bit by bit. So this one says find the actually no, that's not the right page. That's not the one you're on, is it? Put that first page in the wrong place. That's it, isn't it? No, it's that one. Okay, that's your first page. We've put them in the right order. So finding the scale factor. So that's what SF means. Now, when you apply any kind of transformation, what becomes the what? What's the vocabulary? The something becomes a...
The image becomes the
Other way around. The object becomes the image. So, in this case, which one's the object? A. A is the object, and A dash is the image. How do you know A dash is the image? Because the dash, yeah? The dash means it's the image. Okay? So, scale factor, what does that mean to you?
The scale in which you are increasing the...
Yeah, how much you're increasing it by. Or decreasing. Now, a scale factor, what does factor remind you of? So when you factor, what operation are you looking at? Multiplication, is it? When you find the factors of a number, you are looking at what multiplies. So when we are scale factor, we're looking at something that multiplies to get, what do we multiply by to get the new shape? Okay, so I think you've picked it, haven't you? So what we can do is say any of the sides, and this is where you might have to add to your notes, maybe you can write it on the sheet or not, any of the sides, so we can look at that side. I'm not going to measure it, but I know it goes through those shapes, 2 of those squares. So if I look at this side, look, I've got one of those, and the second one, and a third one. Okay, so it looks like The scale factor in this shape is 3. So we can say all sides are times 3, and we're going from that side, so we're going to the same side of from the object to the image. Okay? And just one thing to add, what do you notice about those sides compared to each other? Just a little side note. The sides are, okay, we would also say parallel. So that side and that side are parallel. That's how you know if you've done an enlargement correctly. So I can compare different sides. So if I want to look at this side here, it's 1, 2, 3, 4. This one is 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So again, it's multiplied by 3. Okay. Oh, I did that wrong. 1. So that side, so the scale factor would be times 3. Alright. And you'll notice those two sides are parallel, and so are the final two sides. How do we know they have to be parallel? Because similar shapes have to have the same what? Angles. The angles never change in similar shapes. The lengths of the sides do. If you keep things at the same angle, they should then be parallel. Have a go at the second one then yourself. Now we are. Okay. So we've got the second one. I think most of you noticed that this is the object. Okay? That's the object and this is the image. Therefore you notice that it actually gets smaller. Alright? So I pick a side. So let's pick this side and compare it to this side. Right. And decide what's happened. So actually what I could do is consider it in reverse. So how many of them go in there? 3. So you may not have decided to do it like this, but just to show you something, if I do it in reverse, image to object, it would be times 3, no?
Yeah.
Okay. But I need it object to image, so I can't times 3, so you would say what's the opposite of times by 3? It's
1 over 3.
Divide by 3, but we're not allowed divide by 3 because that's not a scale factor, so we have to times by 1/3. So that's the scale factor.
Yes, good job.
It is a third, each length is a third.
So basically, you just do 1 over whatever it is. So because you have
Sometimes though it might not be as easy as a third, it might be 2 over 3 or something. But okay, any questions on that?
So because this one goes from bigger to smaller, you have to times by a fraction because a fraction is another way of division. 1 over 3 is 1 divided by 3. So that's why you go from a big one to a small. Are you just making someone sense?
Yeah.
So therefore you have to, the reason why you have to times by a fraction is because you have to multiply. And you can't multiply by a big number because then you'll be increasing, not decreasing. And it is definitely not
I disagree.
That is
Right, so an interesting point is to look at not just the lengths but the areas. Okay? Now do you remember the area of a triangle? How do you work out the area of a triangle?
Base times height over 2.
Base times height over 2. So the area, let people who are a bit quieter get involved. So we've got nice here, area is half base times height or base times height over 2. So this one here is quite nice. So we've got the base is 4. 4 times 2 is the height, divide by 2. So it's 4. The area is 4. of the object. What about the image area?
Same thing. 4 times 3.
Same area. It's obviously not, it's much bigger. Do you think it's times by 3?
Yes.
So it should be 12?
Yes.
Alright, well let's work it out. Base is 12 times height is 1, 2, 3, 4, 5, 6. Divide by 2 is 36. Right, so we actually go area-wise 4 to 36, which is times 9. So does that mean there's no relationship between the lengths and the areas?
No, because you're timesing everything by 3, like every side by 3. So 3 plus 3 plus 3 is 9.
Not quite. I thought you were going to give me the right answer. Not quite.
Oh!
Because... No, I'm going to tell you why. Because if it was a square... If it was a square, Julianne, it wouldn't be 3 plus 3 plus 3. Now, what you might notice is, what are the units of length? So, let's say centimetres. So let's say that's 4 centimetres, therefore this would be 12 centimetres. There you go. You've spotted it. So the units of area would be centimetres or square centimetres, 36 square centimetres. So with area, instead of multiplying by 3, we think of it as multiplying by 3 squared, which is 9.
I was going to say that.
It's what you meant.
Yeah.
I knew it was what you meant. Yeah. Yeah. So there's a big link there. So whatever your scale factor is for the length, the area is the same scale factor but squared. What do you think if I had a 3-dimensional object?
Times by cubed.
So times it by cubed, yeah. So if each length was times 3, the area would be times 3 squared, the volume would be times 3 cubed. Okay? So what about this one then? Without working out the area, what do you think the area would be multiplied by?
So, 1 3 squared.
Well, if the lengths are multiplied by 1/3,
Just 1/3. 3.
1/3 squared, right, Alison? So what's 1/3 squared? What's 1/3 squared?
Oh, isn't
1/9.
No, 1/9.
1/9, yeah. So 9. Oh, did you say?
No, I
Just
named
ignore
it.
that. You said 1/9, I heard it. Right. So that means that this shape, it makes sense, because if you went the other way, this one is obviously 9 times as big. So if you go the way we want to go, it's 1/9 of the size. Alright? So that's that link between lengths and areas for you. Everyone okay with that? You need time to add some notes?
Yeah, please.
No, that's the end.
Well, if you want some time, if you're fine, go on to the next page, have a go and see what you can do. Right, let's have a look at what the next important point. Now, do you remember we talked rotation, the other one that has a centre of rotation? What did moving the centre of rotation do to the image?
Rotated it.
Changed where it was, not rotated it, it changed where it was, okay? It's the same with an enlargement, but what we need to do is figure out how we're going to use it. So there are 2 ways, all right? One of them you will need for something else, and one of them you'll see. So enlarge by a scale factor of 2. So what all the lengths are going to be multiplied by 2. The centre of enlargement is at 0, 2. So what you need to do, and you need to show this, mark that centre of enlargement. So 0, 2. Here is your centre of enlargement. All right, at 0, 2.
Why is that?
Why?
It says it right there. No, but like.
Oh, that's just where they say. A lot of them will be at 0, 0 at the origin, but they might move it. So wherever the centre of enlargement is. Imagine, it's like I used to do this, have a torch in your hand and point it at someone, and then look at where their shadow is. Yeah?
Oh, I know what you want.
So if I move the torch around, your shadow moves. So it's like that. So you'll see what I mean with lines we're going to use in a minute. So there's two ways of doing it. I'm going to do, the first way is you take each point on the object, okay, and you look at how far it is relative to the centre of enlargement, okay. So I know that this point here, I'm going to call it point A, is 3 across and 1 up. Like I said, this is only one way of doing it, so you might remember it different. Therefore, my image is, the image of point A is going to be 3 along and 1 up twice. So I go back to my centre of enlargement and go 1, 2, 3, up 1, 1, 2, 3, up 1. Now you can either do it as 6 and 2 or do it 3 and 1 twice. However you want to do it. So my image of A is there. There's A dash. And if I do that to all the points, alright, so B for instance will be across 3, down 1. So I'm going to do that twice. Across 3, down 1, across 3, down 1. Now people make a mistake because what they do is they go across 3, down 1, I'll do it twice. And they start from this point. So they go across 3, down 1, across 3, down 1, and they get it too big. So remember, you always start from the centre of enlargement. So I've gone across 3, down 1, go back, do it twice. So B dash is there. And I'm just going to do C up here. Right? I'm going to go across 4, up 2. So I've got to do that twice. Across 4, up 2, across 4, up 2. So C dash is up there. Now, once I've got enough points, I don't necessarily have to do it for them all, because once I've got a few, it's probably easy enough to see that, well, B's that's the straight side, and that's to the top. Now, remember, I can't change anything other than the size, so really, I just have to make the shape symmetrical like it was before. So I don't need to worry about the rest. How do we check we've done the right thing?
How did you get C?
Parallel lines. Are all my equivalent sides parallel? Yeah? Are the lines twice as big as they were before?
Of course.
Now, one thing you might want to check is this. Another way to do it, you'll have a look at the board, because you might want to try this for one of your other points. I can measure from the centre of enlargement to the point directly, and then double that length. So if it was that length, I'm going to double it. And you notice it's there. Same thing for B, look, go down there, double that length, and the point should all lie on these lines. Do you remember I said about having a torch beaming out? Same with point C, look. If I go through point C, the other point C should be on it. And if I pick the other points that I've not done yet, if I've done this correctly, they should all lie on these lines, the ray lines. Right. So there's two methods to do it. However you want, you either go direct route or you do the cross and up or a cross and down method. Right? But as we say, we've got a scale factor of 2. Check your lengths. Check your lengths. Check sides are parallel. So just to make that clear, this side here should be parallel to that one, and the image should be. Have a go at the second one yourself. Scale factor of 3, centre of enlargement is moved. So I'll put it in a different
Okay,
place.
so then we did.
Let's go through question 2 just quickly. So my centre of enlargement is at 1, 3. So I'm going to put that point at 1, 3. And everything has to be multiplied by 3. So I'm going to do it this way with my lines. So I go through there. So I go 2 along, 1 up. So I'm going to go 2 along, 1 up, 2 along, 1 up, 2 along, 1 up, and my new point is going to be there. Okay? So I'm checking it is on that line, that point there. Point A is there, A dash. Now, as I get more knowledgeable, I don't need to go straight back to this all the time, my centre of enlargement, because once I've got one point, I know all the other lines are times 3. So actually, I can just look at what they were and multiply them by 3, and they have to be parallel. So this point here, look, it goes through 2 like that, but I have to do that 3 times. Alright? And that one goes across 3 and up 1. I have to do that 3 times. So my new shape. So I can either use the centre of enlargement every time, or I can use the fact that I know the sides are all multiplied by 3 as well. Basically everything's multiplied by 3. Is that alright? Any questions? Don't forget, and this is one thing that really frustrates me actually when I see it in exams, the sides should be parallel. You would not believe how many times I see answers like this. And you kind of think, all you've done is counted wrong, but you kind of, you know how to do it, you've counted squares wrong. And it's obvious because the sides aren't parallel. Alright? So just check. It's one of those you obviously didn't check. So what's the next one you want? It's, which one was it? This one. Okay. So my scale factor is 1/3, which means it's going to get smaller. It's going to be 1/3. Every length is going to be 1/3. My centre of enlargement is at 1/4. Again, make sure that's in the right place. You'd hate to get that in the wrong place. Right? How do I want to do it? However I wish. So I can say, to that point for instance, I've got that distance. Now I can either do it as a direct distance on the line, so I know my point will end up somewhere on this line. It's got to be. In the same way that this point up here has to be on this line somewhere. So what I need to do is just figure out whatever that distance is divided by 3, because it's 1/3. So I can see nice and easily, look, that's split into 3. So I'm going back to my centre of enlargement. Instead of doing the whole thing, I only want to go 1/3 of it. So if that's point A, this one here is A dash. Alright? Again, this one here, if this is point C, I'll call this C. If that split this line into 3, I can see nice and easily that's splitting into 3, because it's where it crosses, it'll be like that. So if that's the length, this one here, okay, that will be C dash. Now I can do it like that, or, if you bear with me, I can say back to A. So instead of down 3 across 6, I can do 1/3 of it instead. So I can just do down 1 across 2. So I can do it that way if I like. So instead of down 3 across 2, and I can check, look, if that's right, if I do the opposite, it should be 3 lots of that, which it just happens to be. Okay? So however you want to do it.
I am going as well.
So now, I've got this point, I've got this point. I actually don't really need to do the others in the same way, because what do I know about all the lengths of the sides? From big to small, they are going to be parallel, and how much smaller? 1/3. So this side here from A, so I'm at this point, from A it was 3, how long is it going to be in the image? 1, that's actually good. So I'm going to go up 1. Oh, sorry, I need to get rid of that. Like that. So I'm just going to go up 1. And then from that point there, I go straight to C. So instead of going through 1, 2, 3 squares, it's going to go through 1. And then I can finish it off, really. I don't need to do all the points. What's my checks? Are all sides parallel to their originals? So yeah, this line here is parallel to that line there. This line here is parallel to that line there. Okay. Now, what do you notice? Go on, sorry, which question? The second one. Okay. What do you notice about this second one? So the centre of enlargement is...
It's going to be inside.
It's inside. So 8.5. Okay. Alright, so the centre of enlargement is inside. But that's not a problem. We still follow the same rules. Alright? So, which method do you prefer? The line method or the left and right method? The line method? Everyone happy if I do that? So for instance, I'm going to go from here up to that point. And I need to make it a half. So I only want to go half as far. So instead of all that way, that's half of it. So my new point, if that's A, this is where A dash is. I'm going to go to this point out here. So instead of B, I'm going to only do half of it. So B dash is there. I'm going to go out to point C. I'm only going to do half of it. So C dash is there. And if I draw my triangle again, this is probably a real one where something will happen where you won't end up with parallel sides if you don't count properly. You'll notice, look, the sides are parallel on the object in the image. So the image can be inside, it can be wrapped around, they can overlap depending on where it is. Okay? Any questions on that?
Maybe they're not
individual.
Okay, so I've got to apply a transformation here, an enlargement, and it says it needs an enlargement of -2. Now, I have said this to a few of you. A lot of people initially think a negative is what you do and it gets smaller, but it doesn't. So -2. Basically, the way to look at it is, before, if I went straight from that point there, from the centre of enlargement, if it was a scale factor of 2, I would do that twice. And that's the new thing. However, when it's a scale factor of -2, we figure out that distance, but we do it in the opposite direction twice. Okay? So point B, B dash would be there. And in the same way, if A is down there, so take that distance, double it, and do it in the opposite direction. Okay? So A dash would be up there. And in the same way, look, if C is there, distance of 4, take it and do it twice. Have I got that twice? Yeah.
That's what I got.
Okay. So then you've got your new triangle. Now you will notice then that not only is it larger, but it is also the opposite direction. It's kind of, some people would say it is an enlargement and a rotation, because it's not a reflection because it's flipped upside down as well. It's not really. Okay. It looks like it is, but it's not an enlargement and a rotation. It's just. But you've got to look at it and think, would I be able to recognise if it was a negative scale factor if I'm given two objects? Right. So I think you then, on the whole, what was it? The next ones, you got the whole thing about the lines pretty well, didn't you? So, do you know, this is a question I didn't know for years what an easy way to do it, because I never used the lines to do my enlargement. I always counted the squares. So I was like, how is there an easy way? But it is easy, isn't it? You know these points have to be on the same line. So if you join the points together, where all those lines cross,
OMG!
that's the centre of enlargement.
You guys are looking at this like
You relax.
So, same with this one, look. If I join the B's together, but this time I have to extend it, but I have to be careful, don't I, that I actually draw it properly. So it's across 4 down 3, cross 4 down. So that's where it be. And in the same way I go through C, it will end up there, and point A, it will end up there. Okay, so that's where my centre of enlargement is.
Because then they won't cross.
So, again, the problem is people that are a bit careless, don't count squares properly. What sometimes happens is people do something like this and they're a bit haphazard. I get something like that and go, right, now I'm stuck.
Mr. Butts, may you redo that one, please?
Okay, so I'll do it again. So I'll pick a nice easy one. So I'm going to start there, and I know it's down 1 across 3. So I'm going to keep doing the same thing, down 1 across 3, and that's kind of it. So I know those 2 points lie on the line. So this point, if I'm not quite sure what's happening there, I know I have to go down 4 across 3, so I'm going to do it again, down 4 across 3, and now I know it's both on those points.
Oh, so the distance between.
Yeah, so it's just like applying the enlargement in the opposite direction. Okay.
You get it, Abby?
Right, just final quick before you pack up. All the lengths are multiplied by 2. What's the area multiplied by? 4. If the area is 16 times bigger,
4.
the lengths are all 4 times bigger. Okay?
Oh, so this is square root?
Just final check. Cool. Have a good evening.
Ah! Oh,